Hey everyone, welcome to the data structures tutorials. In today's episode, we are going to learn more about queue data structure. We are all familiar with the word queue, right? No matter where we go in order to buy tickets or what else? Wait for our turn, we have to stand in queue. So there is a data structure for it, right? It's a fundamental data structure in computer science, because computer science also, a lot of things need to be done in a queue, in an order, okay? It's a linear collection, okay, with two main operations. Enqueue, okay, this operation adds an element, okay, to the end of the queue, okay? It also refers to as push. So basically, if there is already a queue and you go in the end and go and stand in the queue, so you will be at the end, last, right? Unless somebody else comes behind you. Similarly, that is there. Then the other operation is deck, which removes, or rather dequeue, which removes the element from the front. So let's say if you're standing in a ticket queue, you took the ticket, so you get out of the queue, right? The first person who's there gets the ticket first and gets out, right? So this is also known as pop. So in normal, regular implementation, pop removes the first element that was added from the queue, and push operation adds a new element to the end of the queue, okay? So it follows the principle of first in, first out. The element which was added first has to be taken out first. Okay, it's used in so many queue implementation like RabbitMQ, Kafka, all the what do you call the messaging apps. It's used in there too. Okay, so the first element added in the queue is the first one to be removed. Okay, in other words, the elements are processed in the order in which they were added. The various practical implementations purposes of queue, for example, in task scheduling, right? In operating systems, you have to schedule tasks to ensure the fairness of resource allocation. Breadth first search, if you haven't seen the video for my tree data structure implementation, please watch that. In breadth first search, wherein you have to search the queue, all the elements in the same level of the tree, you use queue implementation. Print queue, like in a printing system, you send a print job, right? And it goes again in the first come, first serve basis. Task processings, in multi-threaded processing, queues are used to manage tasks. Okay, it's also used in the messaging app like your WhatsApp. So the first message sends appears first in the beginning, right? Food delivery apps, whoever order first, they are first in the queue, right? Various usages of queue data structure. There are different implementations of queue. Linear queue is the basic. In a linear structure, new elements, what we were discussing so far, new elements are added at the end, and older elements, or if it's a removal, it's removed from the top of the queue or the first beginning of the queue. Circular queue, it is used for buffering, wherein the last element has a pointer to the first one again. That way, they form a circular structure. Okay, priority queues, wherein elements are not popped in the order in which they were added, but it needs a comparator, and the comparator will decide which elements should be popped, okay, or dequeued first. Double-ended queue, okay, a queue that supports adding and removing elements from both sides. Okay, so it's a very versatile operation. Blocking queue, it's used in synchronization mechanisms to handle concurrency, okay, to handle concurrent access safely. Okay, all right. Let's see this in actual action, in working action, right? For today's purposes, for today's lecture purposes, I will be demoing priority queues, not the regular queues, because they're a little bit more interesting. So basically, it's a simple implementation wherein you have a person and you retrieve a person in the order of the age, okay, person's age. So, and obviously this is using Java. So we have a comparator wherein we implement the comparator interface. It compares, you pass in the objects of two persons. The integer.compare compares the age. Okay, so you call the method compare on the integer class, and it'll just compare the two ints value. So if you hover over, it will tell you two int values numerically. The value returned is identical to what would be returned by value of x compared to integer.value of y. That's just the Java docs, which IntelliJ shows up. All right, so here is the demo. Basically, what you're doing is creating a PriorityQueue object, which we imported. Here, it's a part of util, and we also have a comparator. Okay, PriorityQueue is equal to new PriorityQueue, and you pass the comparator to it. Okay, so here it is, the age comparator, which does nothing but simple. It implements or overrides the compare method and just returns whether the two values are equal, less than, or greater than. That's all it does. We add three persons to the queue, okay, with name and age. And what we do is just retrieve, we call the poll method, okay, which will retrieve an element, retrieves and also removes the element, okay, from the queue. Poll method, okay, and we're just printing it out. So since we have implemented the comparator, the order that we are expecting is first it should be Bob, then it should be Alice, and then it should be Charlie. All right, let's see in action. Here you go. And it's going to compare, and there you go. So as we expected, Bob, Alice, and Charlie sorted by their age in ascending order, right? So that is it, all about queue. Very simple, but very, very useful. Okay, so again, a linear data structure with tons of usage in different aspects of computer programming, where the most common implementation or functionality is first in, first out in the queue. Again, as if you were standing in a queue for something. So that is it. But again, in Java and other programming languages, you have different implementations also available, like for circular queue, priority queue, double-ended, which is doubly linked list, I think, is available in Java. So a lot of things available and a very useful data structure. Hopefully, after hearing this lecture, you know a little bit more about queues. Feel free to add any comments, suggestions at the end of the video. All right. Thank you all. See you all in the next lecture. Bye.